So the project CABESTAN, the aim of this project is to work on the carbon cycle on intertidal zone of the French Atlantic and Channel coast. So the main objective of this project are described on a poster that will be presented this afternoon. But briefly, so we want to study the flux of carbon in intertidal zone and the processes responsible for these fluxes, and also the sequestration of carbon and the nature of organic carbon that is sequestered in the sediment. So from the south, the Arcachon Lagoon, to the north, the Canche estuary in the channel. We want also to do some upscaling at the end of the project. The main highlights of the first year of the program this year. First, we had to choose specifically the study sites, which is not very easy to choose the good study sites because they have to be representative. They must be accessible, so there is a logistic problem. And after, when we need to do some upscaling, the sites must be representative of for this upscaling. We have also four new PhD start the PhD this year. They are not funded by CABESTAN directly. They are funded by doctoral schools, regional program, regional council, and other associated programs. So this is supplementary manpower for the program, for the CABESTAN project. During this year, also, all the researchers of the work package 2 and 3, so the work package devoted to flux and processes studies, went together on the field, on the Canche estuary. So we were more than 20 researchers. And the objective was first to study the Canche estuary, but first of all, it was to share our techniques, our methods for sampling, and then after for analyzing the sample. And so the objective was to select to show, for each lab was able to show all the techniques, and so to get the best methodology for the study of the other sites for the next years. So this was an important step in our program. And I show you an example of first results. So we, during the thesis of Paul Canfer, we get some initial results on the flux of carbon that is sequestered in the form of alkalinity in salt marshes. And so in a 1 square kilometer salt marsh, there is a flux, a significant flux of carbon in the form of alkalinity. This is a sink for CO2. And if you want to know if this corresponds to grams of carbon per year, kilograms, tons, gigatons, so just see the poster tomorrow presented by Paul Canfer. So thank you.